Assalamu alaikum. Hello everyone and welcome back to the good stuff. We are continuing with our first topic, that is atomic structure and the periodic table. Now, as you saw in our previous lesson, we covered the structure of the atom, the electron configuration, first 20 elements, so on and so forth. And in this lesson we will learn the periodic table. Now, without further ado, let's dive straight into it. What is the periodic table? The periodic table is the arrangement of elements with increasing atomic number. As we saw, what is atomic number? Atomic number is the number of protons in the nucleus of an atom. Now, the proton is what defines the number of the element in the first 20 elements. So the periodic table will show us the representation, the location of the element in the table. Now, the periodic table consists of groups and periods. Groups, as you can see, groups are vertical columns. Groups are vertical columns and periods are horizontal rows. Groups are vertical columns. These are all groups. This is group 1, group 2, group 3, group 4, group 5, group 6, group 7 and group 8. Now, what do the groups represent? The groups represent the number of electrons in the outermost energy level of the element. So, for example, let's touch on sodium. Sodium, the electron arrangement of sodium is 2, 8, 1. How many electrons does it have in its outermost energy level? 1. So, this 1 determines sodium to be in group 1. Here is the location of sodium. This is where sodium is located. Group 1 and period 3. What is period? Period is the number of energy levels an element has. For example, let's touch on calcium. How many energy levels does calcium have? The electron arrangement of calcium is 2, 8, 8, 2. These are 4 energy levels. So the period in which calcium belongs is period 4. And the group in which calcium belongs to is group 2. Why is it group 2? Because in the outermost energy level, it has only 2 electrons. Oxygen is number 8 in the first 20 elements. So its electron arrangement is 2, 6. Now 2, 6 shows you that it has 6 electrons in its outermost energy level. That shows oxygen will be in group 6. This is oxygen, and in period 2, because how many energy levels does it have? 2, 6. That's the first energy level has 2 electrons, the second energy level has 6 electrons. So those are 2 periods. So it is in period 2. What do we get from this? We get that a group in the periodic table represents the number of electrons in the outermost energy level. What do the periods represent? A period represents the number of energy levels an element or an atom has. So, as you can see, arrangement of elements with increasing atomic number. We have with atomic number 1, we have hydrogen. With number 2, we have helium. I will explain why helium is in group 8 and not in group 2. Then we have lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium and calcium. So these are the groups, and the groups are represented with Roman numbers and the periods are represented with normal numbers. So group 1 consists hydrogen, lithium, sodium and potassium. In the periodic table in my lesson, we will only be touching on the first 20 elements. Group 2 has beryllium, magnesium and calcium, because in the first 20 elements only potassium and calcium have 4 energy levels. So that is why they are in period 4. 1, 2, 3, 4, period 4. As you can see, these boxes are empty because in the first 20 elements, only 2 elements have 4 periods of 4 energy levels. The others have only 3, 2 or 1. So in group 3 we have boron, aluminium. Group 4 we have carbon and silicon. Group 5 we have nitrogen and phosphorus. Group 6 we have oxygen and sulfur. Group 7 we have fluorine and chlorine. Group 8 we have helium, neon and argon. Now, as you can see here, this shaded part represents the transition metals such as copper, silver, gold, and all those metals are in group and in between this the shaded area. Now for the periodic table, group 1, group 2 and group 3 elements are metals because they lose electrons. Group 1, group 2, group 3 elements are metals because they lose electrons. Group 4, group 5, group 6, group 7 and group 8 are non-metals because they mainly gain electrons. Now with the exception of group 8, because group 8 elements are already stable. Now we will discuss the stable states and elements, while group 4 elements have properties of both metals and non-metals, hence referred to as semi-metals or metalloids. Now we have two types of stable states. We have the octet state. In this state, in the octet state, the atom has 8 electrons in its outermost energy level. That is the octet state. These are stable states of the atom. In the duplet state, the second one, this is octet state and the second one is duplet state. In this state, the atom has 2 electrons in its outermost energy level, and it has only one energy level. Note, duplet state has only one energy level. Now we are going to learn ion formation from the elements, how atoms become ion by losing or gaining electrons. That is the basis of reactivity in atoms. So, ion formation. Atoms lose or gain electrons to become chemically stable. What do I mean by this? These two types of stable states, octet state and duplet state, that is when an atom is stable and it is ready to react, whereas it loses or gains electrons. Now atoms lose or gain electrons to become chemically stable. That is how they form ions. For example, we have an atom of sodium. The nucleus as we know, as I showed you in the previous lesson, this is how sodium will be represented, and we draw the electrons on it. So the first energy level has a maximum of 2, the second has a maximum of 8, and sodium having 11 electrons minus 10 has 1 electron in its outermost energy level. Now this 1 electron makes the atom unstable. So this electron is lost by the atom sodium to form a sodium ion. This is the nucleus. 2 electrons in the first energy level. And 8 electrons in the second energy level. Now this electron, this valence electron, this electron in the outermost energy level is lost, and so the energy level, the third energy level in this atom, it has how many energy levels does it have? It has 3. 1, 2, 3. In this ion, this is sodium atom, and this is sodium ion. with a charge of positive 1. So this is the sodium with a charge of positive 1. How is this positive 1 coming from? Now let's go back to the previous lesson where we learned an atom has the same amount of positively charged protons and negatively charged electrons. That is what makes the atom neutral. So in this atom, when it loses one electron to form an ion, the protons, it is left with 11 protons and how many electrons? 10 electrons. So this is positive 11 and negative 10. So if you do your simple maths, you will realize that the charge of the ion is positive 1. Now what is that bringing me to? This is bringing me to the two types of ions in chemistry. We have two types of ions in chemistry. We have the cation and the anion. Now what is the cation? The cation is a positively charged ion. A positively charged ion is formed by losing the outermost electrons, electrons in the outermost energy level. So this is formed by losing electrons, the negatively charged electrons, so that the positively charged protons become more than the negatively charged electrons. An ion is a negatively charged ion. This is formed by gaining electrons. Now as we learned the two types of stable states, the octet state and the duplet state. The octet state has 8 electrons in its outermost energy level. The duplet state has 2 electrons in its outermost energy level, but it has only one energy level. Now for atoms to obtain stability, they either gain electrons so that they make their electrons in the outermost energy levels reach 8, or they lose their electrons and lose an energy level so that the electrons in the outermost energy level become 8. That is to maintain octet stability. Let's go to negatively charged ions. For example, we have an ion of chlorine, an atom of chlorine. So we have a chlorine atom, Cl in the nucleus. We have the first energy level, the second energy level, and we know the third energy level because chlorine is number 17. So its electrons are represented as 2, 8, 7. So 2 electrons in its first energy level, 8 electrons in its second energy level, and 7 electrons in its outermost energy level. 1 here because there are 7. This atom is not stable. It wants to obtain octet stability. And now octet stability, as you learned, it has 8 electrons in its outermost energy level. And in this case you can see the chlorine atom has 7 electrons in its outermost energy level. Now the chlorine atom will not lose 7 electrons so that it loses an energy level so that the second energy level is left with 8 electrons. No. The chlorine atom, having been closer to 8 already, will gain electrons from another atom. So this chlorine atom will gain an electron in the outermost energy level. Let's represent it with a dot. And this chlorine atom is now an ion with a negative charge. Negatively charged. Why am I saying negatively charged? Because, as we said, I am repeating, an atom has the same number of positively charged protons and negatively charged electrons. In this chlorine atom, number 17, it had how many protons? 17 protons. And how many electrons? 17 electrons. Positively charged and negatively charged. Now 17 protons and 17 electrons, but it gained 1 electron, so it became 18. So 17 protons minus 18 electrons, you are left with negative 1, and that is the charge of the ion. So our next subtopic is atomic and ionic radii. The radius of an atom, as you know what atoms are, the radius of an atom is called atomic radius, while that of an ion is called ionic radius. We discussed what an ion is. It is the form in which an atom obtains stability by either losing or gaining electrons. Now read this with me, and I am going to explain this carefully. The atomic radius of sodium atom is larger than the ionic radius. The atomic radius of sodium atom is larger than the ionic radius. This is because on losing an electron, the outermost energy level is lost. When the sodium atom with 3 energy levels and 1 electron in the outermost energy level, when that electron is lost, and then when that energy level is lost, how many energy levels are left? 2. So when on losing an electron, the outermost energy level is lost. Hence, sodium positive, which represents sodium ion, has less energy levels than sodium atom. Let's read it again. The atomic radius of sodium atom is larger than the ionic radius. This is because on losing an electron, the outermost energy level is lost. So that is decrease in one whole energy level. Hence sodium ion has less energy levels than sodium atom. Now I will give the example of this practically. I will explain. Let me draw. We have the sodium atom with 3 energy levels. So we have the nucleus, energy level 1, energy level 2, energy level 3. 2 electrons in the first energy level, 8 in the second. I think we are used to do this now. And number 11. So 10 minus 10 electrons, 1 energy level in the third. Now this electron, as it is lost, there is nothing left on this energy level. And what is an energy level? An energy level is an area around the nucleus where electrons are found. So if in this energy level no electron is found, which means this energy level is lost. So this is sodium atom. This atom changes into an ion by losing the outermost energy level and the outermost electron. So this becomes a sodium ion with how many energy levels? Just 2, because the third one, the outermost, has been lost. So we have a sodium nucleus and positively charged. So what did I mean when I said the atomic radius of sodium is larger than the ionic radius? This is a sodium atom and this is a sodium ion. So the atomic radius of sodium atom has how many energy levels? How many energy levels does it have? 3. How many energy levels does the ionic radius have? 2. So automatically the atomic radius of sodium is larger than the ionic radius of the sodium ion. The atom is larger than the ion. Why? Because this atom loses the valence electrons, the outermost electrons, and hence it loses the whole energy level. And the ion has 2 energy levels, atom has 3 energy levels. So which one is less? The ion. So the ionic radius is smaller than the atomic radius. Now that is energy levels. When comparing atomic radii, we look at energy levels and nuclear force of attraction. For example, the atomic radius of sodium is larger than the ionic radius, than the atomic radius of magnesium. Explain. How do you explain this question? The atomic radius of sodium is larger than the atomic radius of magnesium. How do you explain this? We will use protons and nuclear force of attraction. In the first explanation we used energy levels. In this one we will look at protons and nuclear force of attraction, because protons are positively charged and protons on this, let's say on this atom, this is an atom for example, let's say it is a lithium atom with 2 energy levels. Now in this it has protons and neutrons, but neutrons have no charge, and on the energy levels it has electrons. How do you think these electrons, being negatively charged, stay on these energy levels? It is because of the positive attraction from the protons. So the protons cause a nuclear force of attraction. I repeat, the protons cause a nuclear force of attraction in the atom, which attracts the negatively charged electrons. As we said, the protons are positively charged and the electrons are negatively charged. So the positively charged protons attract the negatively charged electrons. This keeps the electrons closer to the atom and on the energy levels, or else they will escape. That is obvious. So let's draw the atom of sodium and magnesium. We have sodium, how have I drawn it? 2 electrons in the first energy level, 8 electrons in the second energy level, and 1 electron in the third energy level. Here, this 1 electron. So this is the atom of sodium. Now let's draw the atom of magnesium. 3 energy levels. Magnesium nucleus, energy level 1 with 2 electrons, energy level 2 with 8 electrons, and energy level 3 with how many electrons? 2 electrons. Now when we compare these two atoms and I ask you which atom's atomic radius is larger than the other one, what will you answer me? The energy levels are the same. So which atom is larger than the other one? We will now look at protons and nuclear force of attraction. So listen and listen carefully. These explanations will be used throughout your chemistry and the atoms and elements. So how many protons does sodium have? Sodium is number 11. So how many protons does it have? Sodium has 11 protons. 11 protons. How many protons does magnesium have? Magnesium has 12 protons. So, as we said, positively charged protons attract, or they strengthen the nuclear force of attraction. The more the number of protons, the stronger the nuclear force of attraction comparing between elements. So if an element has 2 protons and another has 14 protons, which element has a stronger nuclear force of attraction? The one with the 14, because the protons have a stronger nuclear force of attraction. They are attracting those electrons on it. So sodium having 11 protons and magnesium having 12 protons. Magnesium has a smaller atomic radius, or sodium has a larger atomic radius. You can say either magnesium has a small atomic radius or sodium has a larger atomic radius, it doesn't matter. Sodium has a larger atomic radius than magnesium. Reason: sodium has less number of protons, hence a weaker nuclear force of attraction. Let's write this down. The atomic radius of sodium is larger than that of magnesium, or is larger than the atomic radius of magnesium. This is because, now this is just short form, so don't write like this. The atomic radius of sodium is larger than that of magnesium because sodium atom has less protons than magnesium, hence a weaker nuclear force of attraction. So in the atom of sodium with 11 protons and in the atom of magnesium with 12 protons, which atom has more attraction to the electrons? The atom of the magnesium atom with 12 protons. So this is what explains that the sodium atom is larger than the magnesium atom because of less number of protons, hence weaker nuclear force of attraction. Now I will just say verbally, I won't write everything. The same example, use it with magnesium and aluminium. The atomic radius of magnesium is larger than the atomic radius of aluminium. Why? Because they both have 3 electrons. I'm not talking of ionic radius, I'm talking of atomic radius. They both have 3 energy levels. But magnesium has 12 protons, whereas aluminium has 13 protons. So which element or which atom has a stronger nuclear force of attraction? It is aluminium with 13. So that is what compares elements in the same period of the periodic table with same number of energy levels. Also, the ionic radius of magnesium is smaller than the ionic radius of sodium, or the ionic radius, you can replace the ionic radius here, atomic radius with ionic radius, because how many electrons does sodium lose to become stable? It loses 1 electron. How many electrons does magnesium lose? It loses 2 electrons. But how many protons are not lost? But how many protons does sodium ion have? It still has 11 protons but 10 electrons. How many protons does magnesium ion have? It has 12 protons but 10 electrons. So which one is more positively charged? Which one has a stronger nuclear force of attraction? It is obviously the magnesium ion. Our next subtopic is oxidation numbers. Now, what are oxidation numbers? This is the change of a particle when an atom loses or gains electrons. Now we learned that an atom loses or gains electrons to obtain nuclear stability. So oxidation numbers is what gives an ion its charge. An atom loses or gains electrons to form an ion, and an ion obtains its charge from oxidation numbers. So for example, the species or the particle is sodium ion. How many electrons does sodium atom lose to form sodium ion? 1 electron. So it becomes positively charged. Sodium ion positive. Magnesium loses 2 electrons. So magnesium becomes 2 positive. Aluminium loses 3 electrons. So it becomes aluminium positive, 3 positive. Why am I saying sodium is sodium positive, magnesium 2 positive, and aluminium 3 positive? Why? Because the protons are remaining the same, but sodium is losing 1 electron, magnesium is losing 2 electrons, and aluminium is losing 3 electrons. So what is the oxidation number for sodium, magnesium, and aluminium? The oxidation number is, for sodium it's positive 1, for magnesium it's positive 2, and for aluminium it's positive 3. Now these are elements that lose electrons. How about the ones that gain electrons? For example, chlorine negative 1 gains one electron to obtain nuclear stability, octet state. So what is the oxidation number of chlorine? It is -1. What is the oxidation number of argon? As we learned, argon is in group 8, so it's already nuclear stable. It does not lose or gain any electrons. So what is the oxidation number of argon? It is 0 because it does not gain or lose any electrons. What is the oxidation number of oxygen? The oxidation number of oxygen is O2 negative. So oxidation number is -2. Why is it -2? Because oxygen atom gains 2 electrons. It is in group 6. So it will gain 2 electrons to obtain nuclear stability. That is where the -2 comes from. So every ion has its oxidation number in regard to the electrons it loses or gains to obtain nuclear stability. Our next subtopic is valency. This is the combining power of elements. The combining power of elements when they lose or gain electrons. Valency is the combining power of elements when they lose or gain electrons. Now valency can be obtained by looking at the number of electrons an atom gains or loses to obtain nuclear stability. It is achieved by looking at the number of electrons gained or lost to obtain nuclear stability. So this will give us how elements react with each other. Valency is what will allow us to see the formulas for chemical compounds. Now number of electrons gained or lost to obtain nuclear stability will give you valency. For example, what is the valency of sodium? Sodium has valency 1 because how many electrons does it lose? 1 electron to obtain nuclear stability. Magnesium valency 2. Silicon valency 4 because it can either lose 4 electrons or gain 4 electrons to obtain nuclear stability. Sulfur valency 2 because it has 6 electrons in its outermost energy level, so it gains 2 electrons to form octet stability with 8 electrons in the outermost energy level. So sulfur is valency 2 and so on and so forth. Now phosphorus is valency 3. Why? Because phosphorus gains 3 electrons in the outermost energy level to obtain stability. Aluminium valency 3. Why? Because aluminium loses 3 electrons. Now phosphorus 285 gains 3 electrons to form 288. Aluminium 283 loses 3 electrons to form 28 because it is easier for aluminium to lose 3 electrons than to gain another 5 electrons. Now reactivity of elements. How do elements react? Elements react with their outermost electrons. Electrons in the outermost energy level. Now electrons in the outermost energy level are called valency electrons. For example, sodium oxide. Sodium reacts with oxygen to form sodium oxide. You look at the valency of sodium. Sodium is Na and oxygen is O. What is the valency of sodium? 1. You bring 1 over here on the superscript on the right hand side, and oxygen, the superscript on the left hand side, you bring 2 because oxygen is valency 2. Now you cross this here and you cross this here. So the formula for sodium oxide will be Na2O. That's the formula for sodium oxide. Why is it the formula for sodium oxide? Because oxygen having valency 2, the 2 exchanges with sodium and sodium 1 exchanges with oxygen. What does that show you? This shows you that there are 2 atoms of sodium which react with 1 atom of oxygen. Are we clear? It shows you there are 2 atoms of sodium that react with 1 atom of oxygen to form a compound called sodium oxide. Another example, we have magnesium chloride. Magnesium chloride. What is magnesium chloride? It is when magnesium reacts with chlorine. We have Mg with magnesium and we write Cl for chlorine. Now what is the valency of magnesium? Magnesium has valency 2, so you put 2 on the right hand side of the superscript. And what is the valency of chlorine? Valency 1, because it gains 1 electron, so it is valency 1. So you put 1 on the left hand side, the superscript. Then you cross these two. This gives you Mg1 does not count, Cl2. What does this show you now? This shows you that 2 atoms of chlorine react with 1 atom of magnesium to form magnesium chloride. What is the reason behind this? This is because magnesium gains 2 electrons. It loses 2 electrons. Magnesium loses 2 electrons, while chlorine gains 1 electron. So for magnesium and chlorine to react, magnesium losing 2 electrons and chlorine gaining 1 electron, how many atoms of chlorine need to react with magnesium to gain both the electrons? 2. This is what is showing you that for elements to react, for atoms to react, the valency electrons, an atom loses an electron and another one gains, is when both obtain stability together, that is when the compound is formed. Another example, calcium oxide. Calcium oxide. What is the valency of calcium? Calcium is valency 2. What is the valency of oxygen? Oxygen is valency 2. And if you exchange these two, it gives you CaO. Because Ca2O2, so both the 2 and 2 cancel. So it gives you CaO. What is the meaning of CaO, calcium oxide? It shows you that one atom of calcium reacts completely with 1 atom of oxygen. The reason behind this, calcium loses 2 electrons, it is 2,8H2. So 2 electrons are lost, and oxygen being 2,6 gains 2 electrons to form 2,8. So the electrons lost by calcium to obtain stability are gained by oxygen to obtain the same stability. That is when the compound calcium oxide is formed. Another example is magnesium nitride. Magnesium nitride. What is the nitrate? Magnesium nitrate is when magnesium reacts completely with nitrogen. So magnesium valency 2 and nitrogen is valency. What valence is nitrogen? Nitrogen being number 7 in the first 20 elements, its electron arrangement is 2, 5. So for 2, 5 to form 2, 8, it gains 3 electrons. So it is valency 3. Magnesium valency 2, nitrogen valency 3. Then you cross these two. This gives you magnesium, you bring 3 here and nitrogen 2. What does this tell you? This tell you that the 3 belongs to magnesium. So 3 atoms of magnesium react with 2 atoms of nitrogen for both of them to obtain nuclear stability. How many electrons does magnesium lose? It loses 2 electrons. So if 3 atoms react, they each lose 2. So 2 times 3 is 6. How many electrons does nitrogen gain? 3. An atom of nitrogen gains 3 electrons. But there are how many? two atoms. So 2 times 3 is also 6. So the 6 electrons lost by 3 atoms of magnesium are gained by the 2 atoms of nitrogen. This is what is giving you chemical formula for compounds. Now valency can be obtained by using the periodic table. For example, group 1 are valency 1 because they lose 1 electron. Group 2 are valency 2, they lose 2 electrons. Group 3 valency 3. Group 4 valency 4. Now group 5 are not valency 5 because group 5 elements do not lose electrons, they gain electrons, because it is easier for an atom to gain 3 electrons than to lose 5 electrons. That is why group 5 are also valency 3. Group 6 are valency 2 because they have 6 electrons and their outermost energy level. So they need to gain 2 electrons to form octet stability, to attain octet stability. So group 6 are valency 2. Group 7 are valency 1. And group 8 are valency. They have no valency because they are nuclear stable. Our next subtopic is radicals. What are radicals? Radicals, this is a group of atoms that exist and react as a single unit with a net charge. What do I mean by this? Let me give you an example of a radical. The first example of a radical is a hydroxide, which is written as OH negative. Now, as you can see, a group of atoms O and H is a group of 2 atoms that exist and react as a single unit. Now this is a single unit with a net charge, and the net charge is negative. Another radical is nitrate. Nitrate ion is NO3 negative. The single unit is nitrate itself. The group of atoms is nitrogen and oxygen, and the net charge is -1. So that is what we mean by radicals. Now these radicals directly react with elements. For example, sodium can react with nitrate to form sodium nitrate. Sodium ion positive can react with nitrate ion negative to form sodium nitrate. Now the positive cancels this negative, so this will form sodium nitrate. So on and so forth. Now let me give you the other examples of radicals. We have hydroxide, we have nitrate. These are valency 1 radicals. We have nitrite, we have hydrogen carbonate, we have chlorate, manganate, chlorate, manganate, ammonium, hydrogen sulfate, these are all valency 1. These are valency 1. Valency 1. What are the formula for this? What are the formulae for this? Hydroxide is written as OH negative. Nitrate is written as NO3 negative. Nitrite is written as NO2 negative. Hydrogen carbonate is written as HCO3 negative. Chlorate is written as ClO3 negative. Manganate is MnO4 negative. Ammonium is NH4 positive. Hydrogen sulfate is HSO3 negative. Now, what is the common thing in all these radicals? As you can see, the charge -1, -1, -1, -1, -1, -1, +1 and -1. So they all have a valency of 1. Now you don't need to know how they are formed, but if you want an example, let me show you how hydroxide. How is hydroxide radical? Why is it with a negative charge? This is because oxygen with valency 2 negative and hydrogen has +1. So when OH combine, O and H, -2 plus 1, that is -1. So it remains with a net charge of -1. That is how these elements, these radicals are formed. Now you can write this down and we move to valency 2 radicals. Now these radicals directly react with the elements to form a different compound altogether. So this is valency 2 now. We have sulfate, sulfide, carbonate. We have sulfate. This is the most popular, sulfate, sulfite, carbonate. We have dichromate and hydrogen phosphate. How is sulfate written? Sulfate is written as SO4 2 negative. This tells you that sulfur reacts with 4 atoms of 1 atom of sulfur. 1. This is 1. When there is nothing here, it's 1. So 1 atom of sulfur combines with 4 atoms of oxygen to form sulfate with a charge of 2 negative. Sulfite is SO3 2 negative. Now mind the number of atoms reacting and the charge, they are differently placed. Carbonate is CO3 2 negative. Carbonate is carbon which reacts with oxygen. 1 atom of carbon reacts with 3 atoms of oxygen to form carbonate with a charge of 2 negative. Dichromate is CrO7 2 negative, and hydrogen phosphate is HPO4 2 negative. What do we see from this? 2 negative, 2 negative, 2 negative, 2 negative and 2 negative. This tells you that the valency of these radicals is 2. So when they react with elements or with atoms like a sodium atom or a magnesium atom, it reacts with valency 2 as the radical. We go to valency 3. You can also write this down. We go to valency 3. There is only one radical of valency 3, which is phosphate. Phosphate ion. And it is written as PO4 3 negative. What do we mean by this? We mean that one atom of phosphorus reacts completely with 4 atoms of oxygen to form a phosphate radical, a phosphate ion. Now these radicals, for example, react with, let's say, we start with the simpler ones. Let's say a sulfate ion, sodium ion reacts with sulfate ion to form sodium sulfate. Write the formula for sodium sulfate. Write the formula. Sodium Now these are free marks. How do you answer this question? Sodium ion reacts with sulfate ion to form sodium sulfate. Write the formula for sodium sulfate. You will write the ion of sodium first, which is Na with a charge of positive 1, so it has valency 1. And then sulfate SO4 to negative has a valency of 2. So as the same way where you react elements with an element, you react the same way an element with a radical. So you bring this 2, you cross it here, and that 1 you cross it here. So sodium becomes 2 and sulfate remains 1. What does this show you? This is the formula of sodium sulfate. What does this show you? 2 atoms of sodium react with one sulfate ion. 2 ions of sodium react with one sulfate ion to form sodium sulfate. But where is the proof coming from? Sodium having a charge of positive 1 and sulfate having a charge of positive 2, negative 2. This is negative 2, this is positive 1. So for positive 1 to balance negative 2, you have to have 2 positive 1s to form positive 2, which will balance the negative 2. Another example. Aluminium Al3 plus reacts with nitrate ion. Let's say it reacts with nitrate ion to form aluminium nitrate. Write the formula for aluminium nitrate. How do you do this? Aluminium ion reacts with nitrate ion to form aluminium nitrate. Write the formula for aluminium nitrate. You will write the ion for aluminium Al with a valency of 3. It loses 3 electrons, so it has a valency 3. And you write the nitrate ion with a valency of 1. Then you shift 3, you cross 3 here and 1 here. So this shows you aluminium NO3 into brackets 3. Now how is this coming from? Let's write this here again. Focus here. Aluminium nitrate, then into brackets 3. What is this telling you? When you cross the valence of aluminium with nitrate is already NO3. This NO3 is always written as a single radical. Now there are 3 ions of nitrate. 3 nitrate ions react with one aluminium ion to form aluminium nitrate. Why is this the formula of aluminium nitrate? Because aluminium having valency 3 positive reacts with 3 ions of nitrate. However, nitrate has valency of 1 negative. So you have to have 3 nitrate ions to form 3 negative, which will react with 1 aluminium positive, 3 positive to form aluminium nitrate. Now count the total number of atoms in magnesium nitrate. Count the total number of atoms in magnesium nitrate. How is magnesium nitrate written? Magnesium with the Mg, 2 valency 2, and nitrate NO3. NO3, 3 is not for oxygen. NO3 is for the whole nitrate radical. So you cross, this will be Mg, 1 is not counted, and then NO3 into brackets 2. This shows you that 2 nitrate ions react with 1 magnesium ion. Now how many atoms are there in magnesium nitrate? How many atoms of magnesium do we have? We have only 1 atom of magnesium, so that is 1. How many atoms of nitrogen do we have? Nitrogen here is 1, but there are 2. So we have 2 atoms of nitrogen. And how many are of oxygen? We have 3 atoms of oxygen times 2, 6. So we have a total of 9 atoms. How many atoms are in ammonium phosphate? Ammonium phosphate, NH4. That's ammonium and phosphate, PO4, 3 negative. How do you do this? 3 negative, you bring it to valency 3, and 1 you bring it here, 3 you cross, 1 you cross. This is NH4 into brackets 3, the 3 atoms of ammonium, the 3 ions of ammonium, and then PO4. So how many atoms are there? We have 3 atoms of nitrogen, then 4 hydrogen are times 3, so that is 12, plus 1 phosphorus, that is 1, and 4 oxygen. This comes to 20 atoms. Formula of common acids. Our next subtopic is formula of common acids. From radicals we move to formula of common acids. Now all acids contain replaceable hydrogen ions. The most common acids in chemistry which we will learn are hydrochloric acid, sulfuric acid, nitric acid, phosphoric acid, and carbonic acid. Now there are two. Hydrochloric acid is written as HCl. These are all acids. Hydrochloric acid is written as HCl. You must know these formulas by heart. Sulfuric acid is written as H2SO4. Nitric acid is HNO3. Phosphoric acid is H3PO4, and carbonic acid is H2CO3. Now these are the most common acids in chemistry, and you must know this formula by heart. Hydrochloric acid is HCl, sulfuric acid is H2SO4, nitric acid is HNO3, phosphoric acid is H3PO4, and carbonic acid is H2CO3. How are these acids formed? These acids have replaceable hydrogen ions and they react with the radicals. So hydrogen reacts with chlorine to form HCl, hydrogen reacts with sulfate to form H2SO4, hydrogen reacts with nitrate to form HNO3, hydrogen reacts with phosphate to form H3O4, and hydrogen reacts with carbonate to form H2CO3. I'll give you the form why H2CO3 is carbonic acid, because H is 1 and CO3 is 2 negative. So this 2 comes here, this 1 comes here, so this is H2CO3. We move. I hope you wrote these acids and their formulas so that you don't forget. Now these acids will be taught again in different topics. Substances with special formula. We have sodium peroxide, This is when sodium reacts with excess oxygen and we have hydrogen peroxide. This is H, this is sodium peroxide is Na2O2 and hydrogen peroxide is H2O2. We have hydrated iron 3 oxide, which is Fe2O3.2H2O. This is the formula for hydrated iron 3 oxide. Hydrogen peroxide is H2O2 and sodium peroxide is Na2O2. Now, for example, why is Fe2, where is Fe2O3 coming from? Fe, iron has valency 2, oxygen has valency 3, oxygen has valency 2, so 2 here and 3 here, so this is Fe2O3. This is iron 3 oxide, that's why iron has 3, valency 3. If it was iron 2 oxide, iron would have valency 2, so that is FeO. Now I think that's it for today. In our next lesson we will learn balancing chemical equations and learning how to form chemical equations. So we will meet in the next lesson. Till then, goodbye, take care, thank you.